Hey, in reflection journal, many students ask me about IVT theorem, intermediate value theorem, and how to use them. Okay, of course, I explained very detailed in class, but now, since you have any question, I would like to make a video about that. Okay, so the IVT theorem says if you have a continuous function on some closed interval, right? Such that f of a times f of b less than 0. So the condition f of a times f of b less than 0 says one number should be positive and not should be negative, right? Or geometrically, we say one point is above x86 and one point is under x86. So we might have the following picture. This is A, this is B, right? Maybe f of A is above f86. So this is A f of A. And here we have B f of B. Because the product is less than 0. Or here is A f of A, and this is B f of B. You know, since the function is continuous, when you connect these two points, right? These two points belong to the graph of this function. When you connect them, you have a continuous curve. You have a continuous curve. Since this curve is continuous, this curve should intersect with this interval as somewhere, right? Suppose that is C. And this is nothing but x86. So since C is on the x86, the function value is 0. You see, this is just very simple, right? Very simple picture. But this theorem is extremely useful. This theorem helps us to understand whether there exists some zero of the given function or not. C in this case is 0 of m, right? Or sometimes we need to solve in equations, and in many cases, first we need to convince that actually the equation has solution, right? And then we try to solve that. And this theorem help us to understand the existence of that solution. Okay, I just give you maybe two examples, very simple, right? The first example, let's say x cubed plus x minus 1 equal to 0. So basically, for quadratic equations, we know how to solve. But when the degree is higher than 2, so go to 3, 4, 5, and millions, we know. Usually, we don't know. In general, we don't know how to solve that. So first, we need to see if this equation has solution or not, and then we try to solve it. So the left-hand side part is a continuous function, right? That is polynomial. It is continuous function already on the whole number line. And in order to apply IVT, we need some interval, right? But in this case, we don't have interval. So that means we have to choose. We have to pick numbers. We have to pick a suitable interval for us. All right. So if I put f of x equal to x cubed plus x minus 1. First thing I need to write is the function is continuous. Okay. So this function is continuous. So we have first condition. Secondly, I need to pick A and B. So the first point I need to choose is 0. Because 0, you plug 0 into that function, you get -1, right? That is easiest point. So I know f of 0 is 0 cubed plus 0 minus 1, which is -1, less than 0. So that means if I can choose, if I find another point where the function value is bigger than 0, I can apply the IVT theorem. Okay, I can apply the IVT theorem. So here you just play with numbers. x cubed plus x plus minus 1, so you can pick x equal to 1, right? So you have x1 equal to 1 cubed plus 1 minus 1, which is 1 bigger than 0. And then from these two identity, you say f of 0 times f of 1 less than 0. So all conditions in the IVT theorem satisfied. And then we say by the IVT theorem, there exists at least one C where in the interval 0 and 1, right? In the interval 0 and 1, such that f of C equal to 0. So I erase this. We do conclusion by the IVT theorem. There exists C in 0 and 1. This is in, right? In 0 and 1. Such that f of C equal to 0. But f of C equal to 0 means C is a solution of this equation. That's it. That's how we can prove the existence of solution. All right. Now let me show you another example. So without IVT theorem, I don't know how to solve that, right? Let's say example 2. So let's say x 2019 minus 2x 2018. Let's say plus 1, right, equal to 0, which is very similar to the previous example. But or maybe let's pick, for example, here sine x equal to 0, something like that. So just complicated one. And we need to consider if this equation, sorry, this is a, right? We need to see if this equation has solution or not. So the function in here is a continuous one. We are good. At 0, the function value is 0. It's not good at all, right? So we need to pick another one because we need condition f of a times f of b less than 0. Okay. So the only thing is you need to compare this and this because psi takes value only between -1 and 1. So if you pick x very big, you will get f of x less than 0, greater than 0, because the power here is 2019, right? For example, you can pick f of 1 million, something like that. And then you take f of -1 million. You see that? So f of million in here, and then f of -million in here. This is greater than 0, this is less than 0. So that means by the IVT theorem, there exists at least one solution, right, of this equation in between -millions and positive millions. Of course, that is not very good interval because -millions positive is very far from each other. We use IVT theorem to prove the existence of the solution. But if we choose very good intervals in here, so we can locate this solution, it would be better for us if we need to find that. Make sense? Okay, for these two examples, I think, I think this is clear enough, and I hope that you understand this pattern. Anyway, if you still have questions, just feel free to ask me. Okay. Thank you for watching, and if you like such video, just subscribe my channel, and then I will upload other videos during the course. Thank you.